My panelists and my, track honors, they always give me the last because they believe it last is the best. So so you guys thank you so much for staying back because this is going to be the best out of the all. So while my presentation getting up, gave you a little bit background that we're going to present about geospatial and artificial intelligence. So we're going to marry two streams. One is a geography and other is artificial intelligence, and see what kind of beauty it creates for citizen-facing applications and how we are using it day by day. And I have got some wonderful panelists and a speaker with us to share with you their experience and their work. So first question I want to ask, do you wonder, like sometimes wonder, that what is the oldest science on humankind? Anybody here can guess? What's the oldest science of humankind? And the oldest science, according to Rig Vedas, is melting. You melt those and create weapons probably. And the second one is actually the geography and astronomy. Humans are very keen that how they can make, understand the earth and their topography, or people has done that. In fact, during my presentation, I'm going to talk more history. I mean, you thought I'll talk AI, but I'm going to talk a lot more history when I'll go along. And say, with all these human knowledge about geography, and you add the artificial intelligence, which is more newer sciences, you got a GeoAI. And why it is special? Because how you handle those data sets. Because those data has some kind of relationship. There is a spatial relationship, there is a time relationships, and how those algorithms of work differ. So there's a kind of, you don't have to go all detail here, but the sense of that, entire, gamut of AI, whether it's a, supervised learning or unsupervised learning, there is a version of geo-related data handling. So if you have like clustering, there's a k-means for normal data, but there is a DB scan for geospatial data. There's a whole lot of a parallel stream which keep developing. It's a newer science. I'm tracking this industry for 3-4 years, and a lot of improvement has happened over the year, and many more my colleagues will talk about where they invested on. But what this lead to as an advantage? 3 things. The opportunity to all this geospatial data which get generated, whether through GPS or through surveying, how to exploit that, the analytics, and the more important, the last one is the location intelligence. Location is everywhere. And we have great example like Zomato's and Swiggy's and Ola's and everybody using those location intelligence. But what goes behind that? How you generate that location? That is a key topic what we're going to talk about today. Okay? Before do that, I want to put this in a perspective, that how do you generate a location intelligence. The first, you probably will use satellites or drones, and you take many, many photographs. You will surveys and create many, many photographs, and you stack them together to create a high resolution imagery. And that is another AI. You do noise reduction, you do snow identification or cloud identification, etc. And that's how you automate. The next process is how you have to process those data, because satellite doesn't know this photo where it belongs to on Earth, and it's called photogrammetry or orthorectification. It has to get aligned. And there is again a lot of automations possibilities that happen, how you do clustering and some kind of technology. My presenters will talk about it. The next step is which is very important. Once you have aligned, you need to understand those objects, also called feature extraction, that there is a building, there is a school, there is a road, all those aspects has to come. Typically has been done usually in manually processes, but nowadays a lot of automation is coming through using AI or CNN. And actually I heard, I was reading a paper called Geometry CNN. CNN has been typically used in deep learning for image processing. So a lot of pixel-based segmentation on goes while you do a object-related, extraction. And then finally is a publication where your data is ready, analytics ready. What do you do with them? Routing and various kind of algorithms which can be written on that one. And this is exactly a right point when I want to, invite my great friend Nikhil. He's a person of Map My India, and they make a lot of these kind of applications which uses these data sets for the citizen. So I'll invite Nikhil to, tell us about his work, what he is doing.
Good evening. So you set the context, Sanjeev, geography and AI, and how this commingling of geography and AI. Just to let you know, before I'll start once my slides come in, AI has been in vogue with GIS, Geospatial Information System, for a very, very long time. The classification, enhancement, some of the guys who I pulled in from the corridor because there was nobody in the room are from GIS stream, and they know what I'm talking about, that basically it's not a new science or not a new tool within this continuum of geospatial. It existed for a very, very long time. Yeah. So I represent Map My India, which is a India-based location platform company. I won't spend much time in this, but just give you 4 or 5 very important things. We started capturing geography from very scratch. At the time, there was no digital map in India, 1995. When somebody had to do route planning, logistics planning, there was no digital map available. You may have a lot of tools, sophisticated softwares, but you didn't have a digital map, which is the core foundation on which the software will work. So we started capturing. Then we started creating an internet service of the map back in 2004. And first thing that people started seeing, the commoditization of GIS happened when you started seeing the PND, personal navigation devices. That was launched in 2007. We started doing backend and frontend, which we'll talk about, with various IoT sensors and then depicting them on the map. Some of the other important things that we did is Indian geography and didn't have a uniform address code. So allocating one machine-generated 6-digit code to each and every addresses so that there is uniformity. And if somebody has to go and deliver 1,000 places, they don't have to give a very complex structure of addresses, but they simply give those 1,000 6-digit codes and the delivery will be made. And then we had a full-fledged platform that I will speak about. And the scale, because the topic is scale with AWS. So how did we create this mapping platform? And the real scale testing happened during the COVID time when we actually integrated GIS map through APIs with the COVID platform. And millions of transactions people did last year, April, if you recall, the scenario there, we were in isolation center. Where is my isolation center? Where is the vaccination center? Where is the testing center? And starting from hundreds to thousands to millions, and that's the real scale that we'll talk about in a sense that now multi-million transactions could be very easily handled and people made use of. So that's the real scale journey. When we talk about, somebody just before was talking, AI actually works best when the data set is trained, and that requires huge amount of data set. There cannot be a better example in the science of GIS wherein the real big data is right there, because not only in terms of the sensors that feed into this GIS data, very disparate sources of these sensors that bring in and we collate, manage, manipulate, and model these data on. So using that, we have close to 6.3 million kilometers of road in India. About all 8,000 towns are mapped in India. 18 millions of point of addresses close to that, and 15 million point addresses, and I will talk about that. When we create these addresses, how AI is being used in the data set. For this entire platform, which we actually engage with clients, B2B or B2B2C, in a SaaS, PaaS, and MaaS model. These are some of the expanding use cases, not the traditional use cases of natural sciences, agriculture, disaster management, water resources, but the new age wherein you find automotive, e-commerce, food delivery, healthcare, many cases of government. And these are, when I'm talking, we are already serving these use cases in all these sub-verticals. one of the things that I wanted to talk, which was also touched upon by Sanjeev, is this whole continuum of geospatial. What do? We acquire data. And there can be multiple sensors, GPS sensors, optical sensors, aerial, mobile, terrestrial. Now that need to be processed. This is a huge amount of data. And that is processed with different tools and technology. AI is used in creating those tools and technology to avoid these noises and only take something which is required. The second part is what I call is management and modeling. This management and modeling is the crux, because what am I going to use my data for is how I manage this and I model this, and that's how I visualize and analyze that. I will talk about that as to how AI helps us in that. And then sharing, collaborating. All these three forms, process, management, model, and publishing, have a tool of AI inbuilt into it. And I'm saying that because we have created this platform. In all three stages of this platform, we have AI ML properly, as simple as this on the data management side. A simple Excel sheet gets into a map and tells you the address on the map. Looks very simple. But the type of data that we get, very unstructured, CSV files, simple Excel files, no XY coordinate, different type of a structure in India, not like in US, like say 380 New York Street, Redlands, California, 92373. No, not like that. House name, street name, and city name, and that's it. Here you have localities, sub-localities, opposite pillar number 252, right? So when you have this kind of unstructured data, bringing meaning from there requires multi-type of tokens to be created. So this whole notion of tokenization, normalization, managing, and conflict resolution, this all tools we have developed in bringing this management, data management, to various business applications. Very simple, because the topic is scale. This complex system, to getting clarity out of it, and then scaling, is wherein we are using AI/ML big time. Lot of models already, trained to create meaning or extract meaning out of it. Very simple again. Time changes, and the color of, the map interface changes. Very simple. But look at the scale that we are talking about. Search and geocode. Everybody knows that when we give an address and we give you XY coordinate, it's a very simple thing. But a lot of tools actually beneath that works. When you say on a map that this is my location and I have to go there, you think that you are just picking up an address. But that address actually geocodes it. Or in a contract tracing, when somebody came to know as to, oh, you went to that mall, it's a reverse geocoding, taking your XY coordinate from the service provider, extracting an address out of it. Beneath that, there's a whole process that goes in. And a lot of data, now gone is the days when I will make a query of geocoding, it will go to a database, fetch, and give me a result back. No. It's an in situ integration, and that integration happens through a lot of AML tool, which trains with a lot of data, database, a lot of models, these databases. Real-time traffic seems very simple. How do we give you that color that you see on the map? That red designates, oh, it's a very high traffic, amber and green. So the way we do it, and let me explain that to you, again, it's a matter of all models trained on that, is that we take the segment length and say, oh, this is the 60-kilometer speed of the road. However, when I get these probes, we call it, which is nothing but XY coordinate generated by those GPS points or your phone, and actually with a particular pole frequency, they are moving from A place to B place. Supposing that is moving with the speed of 10, we collate that with our existing data sets and say, oh, this is a heavy traffic. If it is going by 60, the more data that we have, the better that we train the database through the models, the better extraction of result will happen. And therefore, people say the more people will use, and that's where citizen participation comes into it, the better result it. And these are all real time. Very simple application, but again, I'm going back to the topic that Sanjeev gave, scale. New flyover detection, very simple, I'll tell you. So supposing we have created using satellite imagery 2 networks. One network of the service lane and there is a flyover going in. I have skipped, I could not make out the difference because there is a road going on and above that there is another bridge, flyover is going on. The minute cars start moving in and we start getting those probes, because those probes have X, Y, and Z coordinate. The minute I start seeing that the value of Z is changing, the self-healing process of the map, which is again trained through this model, corrects that and shows that as a flyover. So this self-healing mechanism is nothing but AI/ML in use. Sanjeev, you are looking at me, I have to be fast? Okay. New road detection. Lot of conflation is required because new colonies are happening, because India is being made every day. It's not like US that one colony comes after 15 years. Every year you go to a new place, you find, oh, ye to kabhi tha hi nahi pehle. Now, it's very difficult to capture each and every location. So what do? We again go back to AI/ML. So if some of the cars are moving, and these are connected cars, some of Map India or many other mapping providers, we are able to figure it out that, okay, these cars are going in this direction, so there is a route there, or one way. Between 8 p.m. to morning 8 a.m., now this is a divided 2 lanes, but only the guidance of the GPS says it's moving only in one direction. Means what? Because between 8 a.m. to 8 p.m., that is a one way. This is what we call as a self-healing in map, and this is all AI/ML, and this is all a scale. We are not talking of a city like Delhi alone, which is itself very complex. We are talking of entire country. And this is, as I'm speaking, in a real time being delivered. And the beauty is that the data is fed real time. It actually goes back, checks on the historical trend, and gives you a result near real time. Lot on visualization. I leave it for my next presenter, because I have a feeling that he will talk a lot about on this. Because this is visualization, people talk about what AI has to do in this. Well, the manner in which we parse this, the manner in which we train the model to show A or B type of features that Sanjeev talked about, in a manner we do, calculating a height based on slope or shadow analysis. These are all trained models. So I'll move fast. So is various other aspects on satellite imageries he talked about, finding out, which is kind of statistical modeling, that if you put a water here and if the geometry is like this, how will where will the water go? All that kind of things that we do in flood inundation, road network. This storefront AI. So if you see Union Bank, so through cameras, we have these moving cameras on a bike or a car, which just captures the image using computer vision and, of course, co-located GPS. What we are able to do, create a signature pattern. And the more that signatures that we have, we train our database more and more, which is able to then extract that feature that Sanjeev was talking about, that, oh, this is a bank. Oh, this is a restaurant. We don't have to do the attribution right there. Through this technology, which is big time used in entire process of processing, capturing, modeling, and then publishing. So this is a real use case, whether you have a road object or if there is a traffic sign, everything is there. And this is what we call ADAS, Advanced Driver Assistance System. Level 3, level 4, all is using that. The street view that you are thinking of, many such kind of thing is already in use in navigation, connected, shared, and electric. These are some of the fascinating stuff in GIS using GeoAI. And what is the final version is our app. All that I spoke about, whether it is routing, it is near real time, it is showing a 3D metaverse on a map, is used in our publishing. And the final form is our Mappls app. All the amalgamation of that you see in the Mappls app, not just I'm talking, but in a real sense, you go and see on your iPhone or Android, Mappls, M-A-P-P-L-S, and you see all these things happening. We don't call it Street View, we call it Real View. So you go to the App Store, pick up this Mappls app, go to the apps version, and you will have majority of important places, real-time view there. I leave these case studies because I'm getting a lot of attention from Sanjeev now. Yeah. Thank you, Sanjeev. Hope this made sense.
This is awesome. Bahut sundar rahal. I can't help you say like something in Mathli, we belongs to same region. My next it's amazing how they have actually built this app for entire India. The scale which is talk about takes years, technology, automations, and innovation, what his team has been doing. My next speaker is Ashutosh. He is the engineering head of iGenesis, has been in multi-decade in GIS areas, and he is going to talk about a lot more how he has done is 3D object extractions on the images and aerial surveys and whatever he gets. Ashutosh, the stage yours, man.
Hi, good evening, everyone. Thanks, Sanjeev. I'm Ashutosh. I am a principal architect, and I lead a software team of Genesis. So, past 3-4 years have been very exciting, especially the COVID and the post-COVID, where our bosses were easily able to catch hold of us, and we used to meet a lot after COVID. So we started planning 3D maps for whole of India. And what we came out with is really amazing. And the immediate need, what we saw is automation. Automation is extracting the 3D features out of the maps. So let me just show it to you. So I'm going to talk about Genesis, us as data creators, a few use cases which we have implemented in AI. What are the roadmap and challenges? So first, we are Genesis, pioneer third 3D mapping in India. We are the first to do a 3D-based optical fiber planning using LiDAR. And this is where the actual work started, extracting of 3D data from the street views and the maps. We do the 3D city at level of detail 3 and higher in India. We have built customized GIS applications for all platforms. We have our own AIML tool, grown tools. So we have built everything within Genesis. And we have recently partnered with Google for the Street View. So I'm going to tell you how we are using our own Street View. A few examples of data we capture in 3D. We do the block models, reality mesh models. We do the 3D street furniture extraction. So what are street furnitures? The street poles, the manholes, the bus stops, a lot of stuff which is required in fiber planning, or even in the end use case for the end user can be anyone. The rooftop assets like solar panels, tower antennas, a lot of things can be extracted on 3D. And of course, navigational signs we can extract. So just categorizing them, let's divide that into two visions. The top vision is the map vision, which we are seeing. And this is the street vision, which is the front vision, where the man's eye view, basically. So what happens on map vision? We do 3D building extraction. We do road width detection. We do rooftop assets, like I told you about solar panels. The street furniture assets we are doing on street vision, which I'm going to show you how we are doing it. The traffic sign classification, what kind of traffic sign it is, and the storefront data. So let's see some of the use cases of building extraction. So we extracted the buildings using drone and the aerial imagery using computer vision. All models have been trained within Genesis. So we have our own vast data. So we use that same data to generate the models. And we have also the LiDAR overlays, where we can get an accuracy of really good, 5 centimeter accuracy of the data. So this is one of the sample rural area where we extracted the rural areas, the boundaries. This is the close-up view of the same, what it looks like. You can see a few clusters mixed up in one building. This is the urban area, zoomed out view. This is the zoomed in view of the same area. And what I'm going to show you right now, it's a very zoomed in view. You see the buildings are not exactly matching the edges. And that's one of the problems. So this data, it's not acceptable for the production. So we have to exactly match the vector data to the edges of the buildings. And that's where we use LiDAR. So what happens is when we use the LiDAR to get the exact 3D shape of the building. That's how it is. So once I know where the building is, I can use LiDAR to extract the whole object out of it. So I get the whole 3D model from there. The next use case is the street furniture, how we are extracting data. So what we do in the street furniture, the manholes, street poles, bus stops, traffic signs, we do all this using 3D computer vision. We extract the location in 3D. Our models were trained with like more than 10,000 masked annotations. We did this ourselves within Genesis. And we again projected LiDAR over here to get its exact location, which is at a centimeter level. And for further classification, sometimes for traffic signs, we do two-stage models where we extract what type of traffic sign it is. So here is some examples. So here what you see is simple. You can see a manhole over here. You can see a traffic sign. You can see a feeder pillar over there on the left, the street pole. So what we do is we use AI to detect these objects. Now, this is not the final picture, because this is useless in geospatial world. What we need is a location of those objects. And the street view is a front eye view. You don't know the depth of the, how much far it is from the location. A human can easily say it's just 5 meters from here. But to do in 3D, we need an exact location. So what we did is we overlaid LiDAR on top of the same AI extracted. And then we just projected rays on it and get its exact position. And then we can classify them using what kind of asset it is. Let me show you another example. You see bus stop over here, traffic signs, some gates, the feeder pillars. So that's how the AI output is. The banners on top, if you can see. We align the 3D LiDAR data on top of it. Now, this is what the computer is seeing. We are not seeing it. So nothing is visual. This is happening in the background. And then we add those points on top of the LiDAR to get its accuracy. Let's see the last example. You see a gate, traffic pole, traffic sign, some manholes. Do the AI part and get the LiDAR on top of it and get the location. This is how we classify the traffic signs. It is not just identifying the signs, but also identifying the type of the traffic sign, what it is. And of course, with its location. So nothing is useful without a location. This is one of the examples where we are extracting the shop names from the street view. You can see on the left bottom where you can see the data coming out of the Indian languages directly from the street view. We are also doing something new in LiDAR, where we are directly identifying objects on top of LiDAR. This is now we are trying to identify a bus stop on the LiDAR directly. And this is pure LiDAR, no images, nothing, and we are able to detect it. A lot of work in progress here. We are going to do a lot of extraction using the LiDAR. This is one more example where we are trying to extract the streets and the traffic poles directly on the LiDAR. So what are the roadmap challenges? Categorizing of these models, location-based, area-based, is a challenge. So we are working on the versioning, of course. For example, the Jaipur buildings are different than the Mumbai buildings, for example. And searching them, quickly identifying the models and then applying them on the data. We are also trying AI directly on the mesh and reality models. That's part of the future plan. We are directly integrating our data now, our logic, into ArcGIS and QGIS softwares or any other software, which can be just like a plug and play to these softwares. The challenges. Performance and scaling, yes. So this is where AWS can be a very good source for us, where Sometimes we have to complete a particular city in like 10 days, 15 days. So we have to scale very fast so we can divide the work and quickly spin up the servers and again, do the detections. And the last challenge is, extracting 3D data from Street View without using the LiDAR. So that's where, like for example, using triangulation methods. So we won't get as accurate as LiDAR, but we can still get the objects, even if there is no the LiDAR on the street views. Thank you everyone.
It's amazing, a lot of technology, and it's all homegrown. It's amazing to hear all those what you guys do. So proud of Now we thought it would be a good idea to conclude with. I have Mr. Dave from US office, and he works with NOAA quite closely, and they do some wonderful use cases. So why don't we talk about those use cases which happen in US again and US market? Dave.
Hey, thanks, Sanjeev. That's the clicker.
Yeah.
Hey, thank you. So I'm between you and a beverage, so I'm going to make this really fast, impactful, and potentially even entertaining. So I am Dev Jodhan, and I manage the relationship between NOAA, which is the National Oceanic and Atmospheric Administration in the US. We've been customers, or they've been our customers and partners for over 5 years. And my job is to essentially help them do what is their mission, or a mission-related operation. GIS is at the core of what they do. And I'll give you an example of this. Primarily, a colleague of ours works in Tuscaloosa, which is in Alabama, which is essentially Tornado Alley. She's working home. She's a stay-at-home mom working with her kids, and she gets a message on her phone saying there's a tornado. Within seconds, she moves to the basement and protects herself and her family. That's the mission that we work for. So why is geospatial and AI important to this mission? NOAA is the authoritative source of all data within the United States. Essentially, it's the multiple data sets that create the national data infrastructure, the spatial infrastructure. This includes geodetic data, nautical charts, coastal elevation, weather, climate models, critical habitat, and observation platforms. And the core of all of this is all on AWS. So effectively helping the mission in its own way. What I'm showing you now is an example of what we have done. It's a rudimentary example, but effectively what you're seeing is a real-time versioning of snow collection. Now this is what we are solving for as the symptomatic behavior, but effectively it's apparently the climate issue itself. We have taken, or NOAA with AWS has taken a proactive and a preventative method. Snow accumulation is collected through several different aspects, which Nikhil talked about, whether it's terrestrial, whether it's optical, whether it's camera, whether it's a GIS methodology. But what it's doing is specifically telling the transportation industry where they should use and what that methodology of reaching a certain goal is. This is a direct impact on the national GDP. NOAA comes under the Department of Commerce, and one of the reasons why it's there is because weather plays a specific role in how GDP is calculated, and weather has a big impact on how we can have a better GDP or a better way of doing transacting business. Another area which we are focused on is, I know you guys have experienced recently extreme heat. What we are talking about, and even Europe had the same issue, we are talking about fire weather. Now, the concept of fire weather is we are trying to measure the meteorological aspects of heat that would effectively manage fire, or essentially predict fire, which is relative humidity, wind speeds, directions, mixing heights, soil moisture, determining whether these conditions are favorable to the growth of fire, and we couple this with the geospatial and location intelligence to establish a specific code of where that fire would move. This is a mathematical model which requires tremendous amount of compute power. What we are doing as a next step is translating that into a mobile methodology. So now we have, potentially by the end of this year, 9,000 fire respondents or first respondents on a Slack channel that will inform them of fire movements. Again, going back to what Nikhil and and Ashutosh and Sanjeev were talking use cases in terms of what's the art of the possible. Now, not necessarily we've gone there, but there is things that I think we should, the Indian context can use for the things that we have done. Nikhil talked a little bit about the water model. So national water model at the NWM is a hydrological model. What that means is essentially it's a formulation of a simulation that allows for observed forecast. That will be a Solon River, for example, a flooded underpass or overbridge and so on and so forth. Overall, this process is mathematical. But what we have done with AWS and NOAA is we are using GIS to prototype a very high-level graphical depiction. The key message being, we could effectively tell where a flood would happen. And this has got tremendous applications on defense, security, agriculture, and so on and so forth. Not every disaster is preventable. So what we're doing now is we're also looking at the actuarial side of things. Damage assessment through multiple channels is another area which we are providing relief, especially from an agricultural perspective. The damage assessment toolkit is built on AWS. It's deployed on AWS using S3 and GIS and even open source data mapping. What it does is through these imagery, it actually gives actual folks and insurance companies the data they need. So the speed to relief, especially financial relief, has been gone from days, months, to essentially minutes. This is extremely important when it comes to agriculture and specifically damage-related issues. I've talked a lot about the weather and prevention and severe storms, but let me pivot a little bit in terms of a project that's really near and dear to our heart, and it's also got a connotation to India. So TCS and BASF came together using AI and from AI and AWS technologies to effectively manage AI technologies with geospatial intelligence to effectively look at agricultural production. So what they did was they looked at imagery to identify weeds, disease recognition, leaf damage identification, pest monitoring, and effectively they did it through several tools within the AWS family. So essentially, the solution used Amazon DB to ingest these images daily. They used S3 buckets to store it. They ingested the data, was divided into formats, and they used Elasticsearch to essentially help field-ready people, so scientists and people in the field, to effectively go on a mobile tablet and do this and increase crop production. So I'll end with the future. As in the keynote, we are now looking at edge computing. Edge computing has become the next level of where we go. So we are now using drones and putting the Snow family of products on drones to effectively use an even unmanned underwater aircraft to effectively map the seafloor. Why are we doing that? We believe, and this is a company called Saildrone, you can look them up on the web and they'll tell you what they're doing. The imagery will help us determine the speed, the velocity, and the damage effect of a thunderstorm or a hurricane, and also manage tsunamis. This is being done this year. There are 7 unmanned aircraft under the sea in the Gulf Coast and the coast of Florida. And what they're doing is actually managing the thunderstorm activity that would take place. And we hope that we can even predict tsunamis, effectively saving lives and life, limb, and property. And I'll conclude with, from what I've seen, there's tremendous innovation in geospatial intelligence. It's a field that is in its infancy. There are great startups like Nikhil and Ashutosh who are doing phenomenal work. And I think there's a great journey to be had if we really focus on it, that they can get to a point where this becomes a paradigm shift in how we look at a map versus how we look at just a map to read it. The level of detail and the level of innovation that can come from it is tremendous. And again, I thank you for your time. And if you